All right, guys, welcome back to another video. Today we are going to be going through Project Euler uh, problem number 6, the summation, the sum square difference. Here's the prompt. It's got some math in it, so rather than copy it in, I'm just going to show it here. The sum of the square numbers, or the sum of the squares of the first 10 natural numbers is 385, and the square of the sum of the first natural numbers is 3025. And we are tasked with finding the difference between those. Only our limit is 100. So this is the simple brute force way of doing it in JavaScript. If you want to do exponents, you'll see that later on. Instead of doing math.pow, you can just do double asterisks. But let's take a look. So first thing we got to do is we're going to initiate variables for each of these. The top variable is equal to this one, and then the bottom variable is equal to this one. Because we're just going through 1 to whatever, it's a simple for loop. And we could, I mean, if you want to make it more complicated, you have a for loop for each. We don't need to do that, though. We can combine it all right here. So in the first instance, we're just summing up all of those numbers from 1 to 100, and then we're squaring them. And in the second instance, we are at each point taking each number, squaring it, and then adding it to the sum. And then when we return it, we return one subtracted from the other. And we can see this is a low enough number that it's not going to take that long. 0.06. Yeah, and you will see that there's a second number popping up there, and that is because there is a second equation down here. That is not the brute force way. So brute force takes a little bit longer, but there is a quicker way to do that. Well, quicker for larger numbers. This is Gauss's summation formula. If you don't know who Gauss is, he's a mathematician, I think from the 1800s, maybe earlier than that. But he basically said, or he basically discovered that, for any series of numbers from 1 to whatever, if you take the limit of that, in our case 100, and multiply that by that limit plus 1, and then divide that product by 2, you will get the sum of all of that. You will get the sum of that series. We don't need that alone. We need to square that. So in the case of 100, it's 100 times 101. Getting ahead of myself. And then divided by 2. Yeah. And then so you would have to square this. I'm not going to do for you here. But that's the quick way to find it. You don't have to loop through and add all the numbers. Very simple formula. There is a generalized formula as well for finding the sum of a series of numbers. If it's just this is the instance of the first one, and then this is the instance of when it's to the power of 2. There's another formula if it's to the power of 3, n to the second power times n plus 1 to the second power divided by 4. And that's for a series of numbers squared. But for to the power of 2, it's n plus 1 2n plus 1 by 6. And if you're interested in this, Alhaber, is that how you spell it? Formula, and that can derive the different instances. So we're using Faulhaber's formula in both of these. In the first instance, we take that and we square it, and then in the second instance, we're just using it. But it is, I mean, this is exactly what we have right here. Is we take the limit number, we multiply it by the limit number plus 1, and we multiply it by the limit number times 2 plus 1, and then we divide that by 6. And you can see that, did I not kill my last instance? Yeah, so let's just go ahead and run it there. It's the same answer. You can do that for anything. Oh, apparently I can't do it for anything. Oh, that's because I haven't passed it in here. Duh. Try that again. Yeah, there we go. So let's there's an easier way to test it. So if I change one, I'll change the other automatically. 10,000. And we can probably start to see a difference in these. See what the difference in time is on these. Oh yeah, it's much faster. Immensely, immensely faster. And that's because all you're doing is just one simple formula. You're not going through and looping and doing a bunch of stuff. So at at this level, you're probably not getting a huge difference. I imagine it's minimal because the time you're shaving off this is obviously much less. That doesn't look right. It shouldn't have been more. Interesting. Huh. Well, I would have thought it would have gone down, but apparently it doesn't. Let's yeah, now you start to see the bigger differences. So this barely went up, and this has gone from it's. I mean, it's gone up by a factor of itself, basically, right? Um, so um, this is obviously the most efficient way to. Well, I think it is the most efficient way to do it. It's definitely more efficient of these two um, by any by any measure. Think of memory is basically the same, not less. Um, oh, it's less because you've got 3 variables up here. You got 2, but the memory complexity isn't really all that drastically different. But the time complexity is much less on this. But yeah, that's basically how you do it. If you want to look at how to do other ones, I think you can probably Google what is it, Faulhaber's formula to derive the other ones. But you can do, I guess, a little bit different stuff with this. But anyway, hope you enjoyed the vid. As always, drop a like, maybe comment, subscribe, etc., etc. Other than that, I'll see you next time.